This is the last problem that we'll be doing in section 4.1. We've got we have this lot, and maybe in some kind of development, and you can see that it's located on a cul-de-sac, and we want to find the area of this lot. And the second part of the problem is going to be to find the perimeter of the lot. So let's take a look at this and see what we're dealing with. If we didn't have this cul-de-sac issue over here, we would just be looking at a trapezoid. Just looking at a trapezoid. But we do have this issue to worry about. So in terms of the area of this lot, if we can find the area of the trapezoid and find the area of this little wedge, then we can just subtract the wedge from the trapezoid and we would get the area of the lot. So that's going to be our plan. So we're going to say the area of the lot is equal to the area of the trapezoid minus the area of the wedge, that little wedge there. Okay, so let's find the area of the trapezoid. Well, here's one base, 85 feet, and here's another one. Is from here to here is 108, but I know that the radius of this arc here is based on a 30-foot radius. So from here to here is 108 plus the 30. So those are my two bases. But what I also need is the height on here, and that I don't know. So I'm going to have to find that. So what I'm going to do is I'm going to drop a perpendicular right here, and form a right triangle. And I'm going to look for that height. I'm going to call it H. I'll look for that height. Now remember, we said that anytime that you had a right triangle and had three pieces of information, then you could find out everything that you wanted about that triangle. Well, I've got three. I know that this is a 90, I know that this is a 63, and I know that this length is 97. And I'm looking for him. So what is this guy to this angle? This guy is the opposite of this angle. So, and I know the hypotenuse. So I'm going to be using the sine function. So I'm going to say that the sine of 63 degrees is equal to, the sine of 63 degrees is equal to H hypotenuse, or opposite over hypotenuse. So that's H over 97. So H is equal to 97 times the sine of 63 degrees. So I've got 97 times the sine of 63 degrees. So I end up with 86.4276. That's my height. So now I know enough that I can find the area of this trapezoid. So the area of the trapezoid is equal to 1/2 my height, which is 86.80. I'll get that decimal out of there. 86.4276 times 85 plus this guy to here, which we said was 108, plus the 30, so that's 138. So the area of the trapezoid is equal to, I already have that number sitting in there, so it's going to be times the 1/2, which means times 0.5, times 85 plus 138. So I get 9636.68. We'll put the other part in there, 10. And these are all square feet. So that's the area of the trapezoid. Now let's find the area of the wedge. Well, there's a formula in your appendix. This is the guy right here. It's for a sector. I like to call it either a wedge or a piece of pizza. And I'm going to want to find the area of that. And it looks very similar to this. I want you to notice that the formula is nothing more. We know that 360 is all the way around, but I only have 63 degrees. So it's just going to be a part of the area of an entire circle. So for the wedge, the area of the wedge is going to be equal to 63 over 360 times pi times the radius squared, which is 30 squared. So the area of the wedge is 63 divided by 360 times pi times 30 squared. And I end up with 494.8008 square feet. Okay, so now all I have to do, what do I have to do? I have to take the area of the trapezoid. Here's my plan. The area of the lot is equal to the area of the trapezoid minus the area of the wedge. And here's the area of my trapezoid, and here's the area of my wedge. So it's 9636.6810 minus, and I'm going to recall that answer, second answer. And I end up with that the area of the lot is 9141.8801. And this again is square feet. Now the problem also says that I should give the answer in terms of acres, and quite honestly I don't recall how many square feet there are in an acre. I think it's 43,000 and some, and so we're going to make up this part of it. This is what it is in square feet, and if I want it in acres, we're going to pretend that it's 43,000, so I'll take that and divide it by 43,000, and so it's going to be somewhere around 0.2126 acres. So this lot is somewhere in the neighborhood, getting close to a quarter of an acre, something like that. Okay, let's do the perimeter part. For the perimeter part, it's just the distance all the way around. This plus this plus this plus this, and oh, we have that arc in there. But at least we have all of the sides from the trapezoid that we need. So the area, the perimeter, not area, we already did area. The perimeter is going to be equal to 108 plus 125 plus 85 plus 97 plus that arc. I'll call it plus the arc. Well, let's go find out what the perimeter of the arc is. We're going to be using this same information about a sector, except this time we're interested in L, the length of that arc. It's the same angle over 180 times pi times r. So that's what I'm going to be using. So my arc is equal to 63 degrees over 180 times pi times the radius. That's what it says, times the radius. And the radius we already said was 30. So the area of the arc is 63 divided by 180 times pi times 30. And I end up with 32.9867. So that's feet. That's my arc guy. Let's go ahead and put the rest of them in. There he's sitting there, so it's plus 108 plus 125 plus 85 plus 97. 447.9867 feet. So pretty close to 450 feet. And that's it.